Hi there, you're welcome back to my channel. So in this video, I'm going to take you through the concept of what limits. So in functions, we have what we call a limit, right? Limits. So when you say a limit of a function, limit of a function, you can even get the understanding right from the word limit, because when you say somebody is limited, or what's your limit, right? Meaning how far you can go, right? I mean, you've ended, or you can't exceed your limits. You get it? So limit of a function is simply means that how far a function can go, provided you are approaching. So provided you are approaching a specific point. So you can't just tell me that the function has a limit without showing me the point where you took. You get it? So provided of the path that you took, a function will have a limit or a point where it can't exceed. That is what we call limit of a point, right? So now, from what I'm saying, meaning that there is a possibility that a function may not end, an infinite function, and such conditions, you don't have a limit because it goes up to infinity and you can never get the value exactly where it will end. Okay, so now let's get straight to the concept of limits, right? This was just an introduction. So under limits, we have what we call left-handed or left hand. Let me make a left hand and what right hand limits. Okay, right hand limits. Now, because we'll be dealing with a function of a single variable, right? This is a function of we are doing calculus 1, right? So a function of single variable. You are going to do our number line. So in a plane, you'll be dealing with x, right? What I'm trying to say is, from the definition of limits, as I explained, I said a limit is always what a function cannot exceed, provided you are approaching a specific point. So if the specific point is x naught, then we can approach x naught from the left and from what the right. So approaching x naught from the left side is what we call left hand limit. Approaching x naught from the right is what we call right hand limit. So depending on the direction you are approaching, so we say left hand limit, right hand limit. Okay, so for the left hand limit, we represent it as limit as x approaches what x naught minus at the top, and right hand limit as x approaches what x naught, we bring what plus at the top, right, to show that it's right-handed, it's left-handed. But in all cases, the limit of a function exists provided that our limit as x approaches x naught negative is equal to limit as x approaches what x naught positive. So as I said, limit is the point where our function cannot exceed provided you're approaching a certain point. And I'm saying that in the raw number line, you can approach it from two ways, either left or right. In all cases, wherever you approach this point, you should get a single limit of the function. If you happen to get different limits, then it means that the limit does not exist. Limit does not exist. So that is what you should have in mind. So always you find your x negative, x positive. If they are equal, fine. Then it means that the limit exists and it's equal to the value you had. Okay. So this is just a brief introduction. Let's go through some properties of limits. The properties of limits. Okay. Some properties. So properties of limits. So for properties of limits, we are going to use, so the first one is, if you have limits as s approaches a point x naught of the function f plus g of x, where both f and g are what functions. So now f of x and g of x are two functions, right? If I want to find the limit of the addition of these two, is the same as what the limit of what each of these. So now I'll say that the limit as f of x approaches x naught is equal to what L, and this one is equal to L prime. So if you want to find the limit of the combined of these two functions, then it means that it's equal to what L plus all this. You just add them. Okay. Number two, when you take the limits as s approaches x naught for what a constant multiplying the function c, the constant c multiplying the function f of x, right? Then you know that the limit of f of x is what L, right? But whenever you are multiplying a constant by a function, you want to take the overall limit, then the limit is equal to the c you multiply times its actual what limit. Okay, take note of this property. Then the third property I'm going to talk about here is limit as x approaches what x naught of f over g. So if you take the quotient of two functions, then the limits will as well be the quotient of their limits, right? L over L prime. L over L prime, right? Yes. So the next one is if I take the limit as x approaches x naught of f to the power n of x. So meaning I'm taking the power of my function x f of x, whilst I know its limit to be L. So the limits will simply be, whenever you get this expression, just take the n out, right? So you write the limit as x approaches x naught of f of x all to the power n. So just open up and bring the n out. And obviously this will give us what? L to the power what? N, right? L to the power n. Likewise, if it were to be the square root, right? If it were to be the square root of what? F of x, then obviously our limit will be equal to what? The square root of what? L. So that is some few properties of limits which I wanted to share to you in this video. So thank you for being with me in this video. Hope seeing you in the subsequent tutorials. Don't forget to like, subscribe, and share.